All right, so I think this is recording. Here they're asking us to simplify this product. We've got a binomial times a binomial, but we also have negative radicands. So we're working within the set of complex numbers, and we know that the square root of -1 is, by definition, this imaginary unit I. See, that's a number. Even though it looks like a variable, it's actually, we treat it as a number. And so we've got 5 plus, well, the negative sign introduces that I, and we know that 64 is a perfect square, so the square root of 64 is 8. So this first binomial is 5 plus 8i. Our second binomial, we have this, we're multiplying the radical by 2. So when we come in and focus our attention on the square root of -4, um, the negative radicand introduces I into our answer, the imaginary unit, and the square root of 4 is 2. But see, remember, we have to take that answer and multiply it by 2 because the problem, that's what the problem is telling us to do. So we've got 5 plus 8i times -6 plus 4i. So when you multiply two binomials, whether or not it's complex numbers, I would do it in a table. And so we've got 5 plus 8i along one side and -6 plus 4i across the top. And those are interchangeable. 5 times -6 is -30. 5 times 4i is 20i. 8i times a -6 is -48i. Excuse me. And 8i times 4i is 32i squared. But we know that I squared is -1. So we know to treat that to just change the sign. If you multiply by a positive one, it would just leave it, alone. It would be 32. But when it's a -1, it changes the sign. So we've got 32i squared is equivalent to -32. So let's come back to our work over here. And along this diagonal, we have -30 minus 32, which is -62. And over here, we've got 20i take away 48i. So that's going to be -28i. And that's our final answer if I haven't made a silly arithmetic type of error. So I hope that helps, and I will talk to you later. Bye.